All right. Well, thank you everyone for attending, kind of our first year of doing these SmartBird sessions. And the folks here presenting here today, we're all very excited for this opportunity to share with you guys, what's passionate to us, which is the design, development, and construction of marine terminals. So I thought what I'd do first is kind of just go through a round of introductions, and then we'll get into the presentation. So I'll start with J.F. Brennan.
Good afternoon, I'm Matt Hogan. This is John Birchill. We're both operations directors with J.F. Brennan. J.F. Brennan is a 100-year-old family-owned marine construction, environmental, and harbor services company. And we've recently expanded to both seaboards, eastern and western, so we're licensed to work in all 50 states on inland and coastal marine terminals. So.
We like to say anything above, below, or adjacent to water we do. We have about 90 divers in-house now, and anything marine construction, environmental cleanup, dredging, locks, dams, you name it. Like I said, above, below, or adjacent to water.
Welcome. My name is Kenneth Bierman. I'm from Superior Lidgerwood Mundy Corporation, also known as SLM. Like J.F. Brennan, we're family-owned, 147 years old. And we specialize in custom winches, hoists, basically anything that lifts, moves, pulls, that's us. And for the purpose of this presentation, talking especially about barge hull systems and our unique approach to them.
Excellent. And my name is Kevin Full. I'm one of the partners here at VAA. I'm also a senior structural engineer. I've got over 16 years of experience in structural engineering design, specializing in the development and design of marine facilities. VAA, I think most of you guys know who we are, but we're a multidiscipline planning and engineering design firm that works on agricultural and industrial type facilities all across the waterways. And our headquarters is right here in this space, right in Minneapolis. I like to say it's at the head of the Mississippi, right where industry starts. But we're licensed in 49 states and 6 Canadian provinces, basically covering all bodies of water. And the type of clients that we work for kind of large facilities all across the country with big marine components that take us from coast to coast and up and down the inland waterways. And the purpose of this seminar, marine projects are specialized. There's a lot of unique things to it. There's a lot of variables that go into a marine project. And really because you're designing a process to load or unload vessels on a public waterway, and all those vessels have many different shapes and sizes, and you're constructing this dock over open water. So the construction of these dock facilities, the constructability of it is very unique. The equipment that we use to load or unload a vessel is very specific to that vessel size and the process, so it's very specialized. And then from a design perspective, we're dealing with a lot of parts and pieces that need to kind of all get harmonized together in order to make that process to work. So it's very specialized in everything from the equipment selection to the operating procedures of the dock to the all the way down to the permitting. There's a lot of parts there. There's a lot of unknowns. So what I wanted to do here today was I wanted to provide an opportunity for us to share with you guys kind of our perspective and our experience with working on dock facility projects. And if you can see in the Venn diagram here, this is kind of at the heart of the presentation. So you've got the 3 circles, the marine contractor, equipment supplier, and design engineer. And what we've seen is, projects where we've got all 3 of those circles fully engaged at the initial phases of the project really influence the outcome of the project. Many times, the 3 of us will be working together on a project, but 1 or 2 of us will be involved at the early stages, and the 3rd one comes later. Again, when you're kind of dealing with just 1 circle or 2 circles at a time, it creates this risk of not identifying the unknowns. So there's a lot of things there that we want to talk about here today. And the graph on the right, this is again kind of plays into what we're saying. The blue line depicts the level of influence at the beginning of a project. So during the first few initial phases of the project, you have the best influence on the outcome of the project. But inverse to that, you have the red line, which kind of represents the cost of making a change to the project. So at the beginning phases, it really doesn't cost much to make a change. But if you got to make a change because of whatever reason there might be, that cost increases exponentially. So again, just kind of undermines the reason of wanting to have all 3 of us kind of perceived as a design team, the marine contractor, the equipment supplier, and the design engineer. But what I wanted to do first is I just wanted to give a quick overview of the inland waterways. And, there's a lot to this topic alone. There's really college courses designated for just this topic. So I'll just be hitting on a few things. First, the United States has over 10,000 miles of navigable waterways designated for industry. And when I say industry, what I'm referring to is the transportation of services and goods on the public waterway. And, you've got all parts of the country have inland waterways. On the Pacific side, you've got a series of harbors and ports along the Pacific, and then up in the Pacific Northwest, you've got the Columbia River, the Willamette River, and then in the central part of America, we have, the luxury of having this Mississippi corridor, the Mississippi and its tributary rivers. And then on the Atlantic side, we've got the Atlantic Intercoastal Waterway, and even in the Great Lakes, we have access to the international market through the St. Lawrence Seaway. So for our economy, we really benefit from having this waterway in place, and our clients that we work for really highly value, and a lot of their business models are based on having this waterway in place. So it's really important to us and our clients' business. And depending on where you are constructing your dock, whether it's in the Pacific Northwest or in New Orleans or in Dubuque, Iowa, the permitting piece to this can vary widely. The permitting component of getting projects permitted in the Pacific Northwest is a totally different animal than, say, in Dubuque, Iowa. So there's just a lot of uniqueness to the waterways that just naturally come with it because you're constructing a dock over open water in a public waterway in a public area. So I wanted to touch on also just the different types and sizes of vessels that we design these dock facilities to. So thinking about, differences in region, depending on where you are, it can dictate, what size of barges. So in the Pacific Northwest, the barges we use there are quite a bit different than what we use in the central part of America, which is also quite a bit different than what we do on the Atlantic coast. But the picture up here on the top, this is a typical hopper barge that we use out in the Pacific Northwest. The geometry of those are roughly about 244 to 300 feet in length. About 42 feet wide is kind of a standard depth or standard width. And they're constructed with an internal feeding hopper that has augers kind of set in, and it helps to unload that product to a central sump that we use for unloading that barge. But what I'm getting at is the facilities that we design, the process, the dock, everything is very much tailored to that type of vessel in that shape. And it's quite a bit different than what we'll do in the central part of America along the Mississippi. Here we use these hopper barges, which is shown in the picture in the bottom. And really, they're not much more than just a giant steel box. And they kind of have a set geometry of roughly about 200 feet by about 35 foot wide. And the only biggest difference between barges is kind of the hull height and also the coaming height on top. But again, we design these facilities specific to that type of barge, being able to remove the lids or work around the lids for unloading or loading. So going to the deep draft terminals, these are the big ships. There's many different types of vessels that are on the waterways. There's liquid tankers, there's, grocery boats, container vessels, and also bulk carriers. So speaking to just bulk carriers, for bulk carriers, they're kind of separated into different classes based on their geometry and also their holding capacity, which are measured in deadweight tons or DWTs. So on the smaller size, you're dealing with a handy size, which is about 25 to 40,000 DWT, to the Handy Max, to the Panamax, and then the Post Panamax getting you all the way up to about 120,000 DWT. And bigger yet, not shown here, is the Cape size. The Cape size is kind of like the Post Panamax, is slightly wider and oftentimes much longer. And also not shown here, thinking about the Great Lakes, the type of vessels that are on the Great Lakes vary quite a bit. On the Great Lakes, you have the Lakers, which are very much just domestic to the Great Lakes, and those go to about 1,000 feet in length. And they're too large to go through the St. Lawrence Seaway locks and dams. But you also have ocean-going vessels on the Great Lakes, and those are kind of termed as salties. And those are kind of more so in the line of Handy Max. They're also categorized as Seaway Max. But yeah, based on what we're doing and where the region this project is, it all plays into the different kind of vessels that it's being sized for and the different sizes of barges. Here's another image just to kind of show the differing sizing of vessels. On the bulk carrier side, the darkest shade is your handy size, going up to the handy max, the Panamax, your post Panamax, and then there's the Cape size. And this little speck here in the center, that's a 6-foot tall person kind of drawn to scale. And it kind of helps you visualize the massive size of these vessels that we design these terminals to. And this is a slide, you know, you've probably seen this concept or this picture before, but it's a favorite one of ours because it really does capture the economies of scale that's leveraged on moving volume on the inland waterways. So one 15-barge tow, and a tow is just a group of barges moved along the river, but one 15-barge tow equates to 2.25 unit car trains, which is about 870 large hopper trucks. But really, once you get south of St. Louis, south of the locks and dams, it's more common for that tow to be more in the 42 barge range, sometimes even bigger. So what that gives you is kind of a multiplier of 3. So for 142 barge tow, we're talking about something like 25 to 2,600 large hopper trucks. So an enormous amount of volume being moved at one time. And to take it a step further and kind of looking at, you know, kind of the big supply chain of, you know, from farm to the export market, you know, all those barges bringing bulk commodities down to the Gulf to be put on a ship to be, you know, sent off to another country for export. But considering, you know, one post-Panamax vessel, 120,000 DWT, I mean, we're talking about 5 15-barge tows, 12 unit car trains, and something like over 5,000 large hopper trucks. So it's pretty significant. And if you're working on a project that has some grant funding tied to it, a lot of these grant funds are tailored to have initiatives with sustainability, climate control, getting trucks off the highways. So oftentimes it's a pretty easy storyline to get, you know, to be considered for additional grant funding. So what I'll do here now is, you know, kind of talked about, that was just a brief overview of the waterways and then, you know, the different sizes and shapes of the vessels that we design these facilities to. Now we'll kind of talk about the different type of dock construction that we design. So when you're doing dock construction, usually the docks are either a floating dock or a fixed dock. So for a floating dock, this is a, you know, what's showing up here is an inland river terminal for a barge unloading process. And the dock of a floating dock construction primarily is just a giant, you know, deck barge that the equipment in the process is supported on. And what that allows you, of course, obviously, is as the river elevation fluctuates up and down, the barge moves with it. So the biggest pro is just that. From an operational standpoint, you're able to load or unload that barge is working off of a constant elevation between the top of the deck and the top of the river. But with the biggest con to this is you've got all of your assets, your equipment, your operations as a whole are kind of supported off of a giant steel box. So if you're working with a facility and considering like a refurbished deck barge that has potential to leak, you know, that you're taking on some big risks there. It's always best to kind of go and get a brand new deck barge designed specifically to the process that you're going to use it for.
And building on Kevin's point there, when it comes to the equipment and actually interacting with it, the nice thing about floating docks is the fact that your haul line is typically in the same location regardless of the water level. However, you do have additional considerations, right? You have smaller space available to you. When you put that equipment on, you have to fly it over. You can't load it from land. So there are some significant advantages to it when it comes to interacting with your equipment, but also some disadvantages as well.
Primarily on the construction side of the world, you know, most of your construction is up front in the construction of that barge from the shipyard and the transport of the barge to site. Kevin mentioned, you know, the limitation of a floating dock barge. Your equipment is now floating on a barge. We mentioned we have 90 divers. We've serviced many old floating barge operations or floating dock operations. But it does offer you a lot of consistency in the way of reach and capacity on the machine it was designed for. So,
definitely need to inspect the dock, you know, on the series of its lifestyle, depending on your what you got there. Like you said, we've seen a lot of rough-shaped docks, and you can look at that offloading equipment. It's not a cheap piece of equipment to be on a rickety, sinking dock, if you will.
So that was an example of a floating dock. Now we'll talk about a few fixed dock types of construction. And again, another thing where we're just kind of hitting the surface, there's a lot of different type of dock constructions, but these are kind of the more common ones that we're involved with. So this is a fixed dock, a multi-use heavy lift dock, and the construction of this is really, you've got a perimeter of steel sheet pile walls, and in the back side of it, then it's kind of filled in with ballast material. So it's almost like you're taking earth and extending it out into the channel. The pro to this is the multi-use, right? You can design it for, you can design the deck surface of this for 1,000 PSF all the way up, to 3,500 PSF, whatever you need for your operations. And you can use that for break bulk, so for your steel coils, containers, just large heavy equipment. But even for just one function, then you can also use that dock space for loading a barge or unloading a barge. So again, there's a lot of different uses you can get out of this. I guess the one con to this is just naturally the size of these docks tend to be a whole lot bigger, and they take up a bigger footprint, meaning you're kind of impacting a bigger spot of the river. So from a permitting standpoint, it's very unlikely you'll probably qualify for a nationwide permit. It's more on the individual side, which just creates more length and time part of that process.
And when it comes to the equipment, I mean, installing it is by far the easiest in a dock like this. You can bring it in by land. You got nice flat concrete to put it basically wherever you want. But when the water level changes, that's really where the complications can become. You have to be able to accommodate loading anywhere from right below that dock all the way maybe down 50, 60 feet, which means your haul cables have to be down there, your winch cables need to be down there, your loader needs to be able to reach down there. In addition to that, barge egress can be a problem too when you have that massive distance that you have to travel to access the vessel. All things to consider depending on your dock and what your goals are with it.
This is actually the dock in our lacrosse yard, so it's a very nice dock, heavy lift dock. We use it often for transloading cranes, on and off barges, our dredges for our environmental group. We take them from the dock, put them in the water, but to Kevin's point, you can store, it has a high capacity as far as pounds per square foot, so you can store a lot of material adjacent to the face of that wall. Some cons, of course, are the heavy materials involved in it. You can see a lot of sheet pile here in this picture. One advantage is, typically, to Kevin's point, you are interfacing with an existing bank. So we often are able to use conventional land-based equipment as opposed to those heavier marine assets, be it barges, lattice boom cranes, tugboats, all of which have to be manned and have a cost. So, but very multifunctional and good for heavy use and heavy lifts.
Just out of curiosity, do we have any dock owners in the audience? Maybe on the phone? I guess we probably don't have a good way of telling, do we? But, okay.
And maybe one more thing to add, when we do fixed dock constructions, we set the top of that dock elevation, to about a few feet above the 100-year flood. So thinking about the river fluctuations, that really does play into what type of equipment you use for that operations. For example, here in St. Paul, the total river fluctuation that we deal with is somewhere between 18 to 20 feet. But once you get south of St. Louis, south of the locks and dams, and say for Natchez, Mississippi, you're now dealing with total river fluctuation of 60 feet, so 3 times more. So you can imagine how much of a gap you would have to work with at low water elevations with a fixed dock structure. So that all plays into it as well. Another example of a fixed dock structure is sheet pile cells. So what we show in this image here is another river terminal where we've got a primary single purpose for this operations, which is to load barges with a loadout tower, your loadout spout, and it's all supported off of a steel sheet pile. So it's a big cylinder. And how those are constructed is it's just individual flat steel sheets installed around in a circle, and then the inside of it is backfilled with ballast material. And the infrastructure that sits on top, typically that's kind of on its own set of supports, so steel piling installed within the perimeter of that cell. So a big pro to this is, and you see a lot of these more so on the upper Mississippi, the Ohio, the Illinois River. These are really, for the most part, getting phased out once you're down south in Louisiana and that neck of the woods. And that's primarily because of the access and supply of the aggregate material and just, the different uses of those dock facilities. But a big pro to this is, this is basically you're creating a giant column of aggregate rock. So there's a lot of mass to it. So it's got a lot of potential energy. It can take a lot of bumps and bruises from barge traffic along that dock.
And because it's so dense, installing equipment and everything like that, you have a nice base to start from. You also have a significant amount of flexibility. When you build a dock like this, as you can see, they actually have the equipment down on 2 floats on the side while having a lot of loading equipment up top. So you do gain a lot of flexibility there. Now, depending on where you place that equipment, again, you can run into issues with changing water level for the cable travels, spout reach, things of that nature. So all things to consider, like Kevin was saying, depending on where your location is.
These are the docks you probably are most familiar with up and down the Illinois and Mississippi rivers especially. They're common in areas with low bedrock, given their mass, as Kevin mentioned. There's no need for socketed piling, typically, depending on the river fluctuation and loading it's subject to. But very common throughout the Midwest and Inland River system, and I'd venture to say being more replaced by the next dock type here that is piling supported.
And part of building these is, the contractor will have these templates prefabricated, and that's kind of used as a template structure to drive the steel sheet piles around it. Another fixed dock structure is the pipe pile. So this is very similar to the previous slide with the steel sheet pile for the barge unload situation, only instead of a sheet pile cell, we substitute it with these individual steel piling. And, really from a, it's definitely more of a straightforward type of construction in comparison to the sheet pile cell. And it gives you a lot of opportunity to implement, ideas or concepts for modularization. And what I mean by that is, because of what we can do here, and what we show here on the right, is we've got a pile jacket system, which is right here at this section at the bracing of those vertical piles. And what we'll do is we'll actually fabricate that entire pile jacket system off-site in a controlled setting. We'll set it on a barge, bring it out to the site, and then put that pile jacket up on some shoring or dummy piles. And that pile jacket then becomes a template for installation of your vertical piles. And then you lock your pile jacket to your piles. So modularization, well, I guess what that also does is it speeds up construction, and it also keeps people off of open water. So it's really important to try to find ways to modularize the construction of this. And you can take it a step further too. The deck surface of this can be, again, same thing. It can be fully fabricated in a controlled shop, put on a barge, brought out to the site, and lifted all in one piece. So a lot of potential for modularization with this option.
Yeah, and the advantages and disadvantages are really similar to that sheet pile dock, but to Kevin's point, if you are installing equipment on top, you don't have to go punch in anchors in the top of a cement cap and use that designated residency. You can actually have your bolt-down locations already predetermined and have everything set up to go the second it arrives on site.
And really anymore, as to my previous point, these are really the dock we put in most frequently anymore. I think on the lower Mississippi, near fault lines too, we see a lot more of the pile-supported dock structures. You can really expand from a platform like this in secondary or third phases. And with the modular construction, we do a lot of the work up front on land without those barges, boats, and cranes I mentioned. So that's all done up in a fabrication yard, then loaded onto a barge, and limits the duration that equipment is on site, and the labor required to man it is costing a job. So a pretty efficient design, and to beat the dead horse, a very modular design.
Mm-hmm. And yeah, to add on that, permanent material costs are usually lower on this, as you would, you don't have quite the heavy steel structures as you would on a permanent fixed dock, as well as the installation's usually pretty quick and cheap. Depending on your subsoil conditions, if you got a socket pile into rock, it does get a little bit more expensive, but for the most part, if you have good soils and you can drive the piling traditionally, it's a overall great versatile dock.
I have a quick question. So these last two options where you have a fixed core, I think you called the two things adjacent to them the floats. How are you positioning those floats? Are they strictly anchored to the center core, or are you also Yeah, how are you positioning them?
All right, so the question is, how are we positioning those floats on either side? Wrong button. So usually, these floating deck barges will be anchored by some capture structures. So either you've got capture dolphins, which are basically an independent pipe pile type of structure, or you have the cell itself. And oftentimes if you have the system, you have to design the system to be able to take that deck barge out if you have to take it to a dry dock for service. But that's usually how it's constructed. They don't just float there. They're not just tied off. They're actually, there's a structure in place called mooring guides that keep that deck barge where it is.
So with these options, if you use the floats, does that give you a lot more flexibility to increase capacity at a later point? Just because you could replace the floats with a bigger float and put more equipment on top of them?
Oh, I'm sure there's opportunities for that. Because really, a lot of times the reason why you see these floats here is primarily just the barge access. How do we get your deck hands close to the deck of the barge? And that's a very big part of a lot of these dock facilities because it's more than just the equipment. It's the equipment, but everyone kind of doing everything harmonized to be unloading or loading a barge. But yeah, to your point though, if you were to phase in some sort of an expansion to it, you could do that with a deck barge.
Thank you.
Yeah, absolutely. So yeah, one last fixed dock type of construction is a wharf, and this is kind of your deep draft terminals that see the big, the big ships, the big post-Panamax ships, and these are just much larger, much longer, and they're farther out into the channel because you're going to have to get that water depth in order for the deep draft vessels to come to the dock. So a lot more infrastructure into these. There's also, for a vessel coming into the dock, there has to be some sort of a breasting system to absorb the energy from the ship, and that's additional infrastructure for that. And once the ship is at the dock, you need additional infrastructure for the mooring, so the mooring dolphins and the mooring anchorage of that dock.
When it comes to the equipment, of course, the cost of these docks are exponential. So when you decide where you're going to put the equipment, you want to make sure you have enough room, if not more. So that's really, when it comes to consideration, these are typically dictated by the region for their necessity. But make sure you have enough room when you build it.
Nothing for you, Kevin.
All right, so circling back to where we originally started about the purpose of this presentation, and again, it kind of comes around, just through our experiences of not having all three of these circles engaged at the initial phase of the project, because this is the critical phase of the project where you have the most amount of influence on the outcome of the project. So what we'll do next is we'll kind of go through different phases of a project, through phase 1, phase 2, phase 3, and phase 4. And then just for reference, phase 1 is kind of like your initial phase, your FEL1, your pre-schematic phase. Your phase 2 is your design development. Your FEL2, you kind of do more of defining the actual parts and pieces of it. And then phase 3 is your final engineering design phase. So starting out in phase 1, one of the first things we'll do is, what site are we building at? And that applies to both just a greenfield site, of course, but also an existing facility. You'll want to do a lot of reconnaissance work, research of the site, and just to find any buried bombs, anything that you need to be aware of, because a lot of these dock projects is having all your ducks in a row and figure it out before you really start moving into the final design phase of the project. So there's a lot of things that we'll look for. We'll work with our clients and do a lot of research for them. There's some really easy things. One of the first easy things we do is we'll just go on Google Earth and we'll look for an aerial photo of a low river elevation condition, and we'll also look at the same photo under a flood condition. And you can see from this image that the entire land side of that site would be totally submerged during a 100-year flood. So what that means is you're going to have to build up your entire site to above that flood elevation and all the access roads. And if you need rail coming out to that site, you'd have to raise all that up as well. It's a pretty simple exercise just to kind of gauge what kind of site we're working with. We'll also study the river. We'll look at the river upstream at the site, the river downstream. We'll look at how the current flows at your site, the magnitude of the current, the direction of the current, and things like that. We'll also look at sediment transportation. Especially if you're building near a bend, we'll look at how do the sediments build and drop near your site. Are we going to have to dredge? Are you guys going to have to do quite a bit of future maintenance dredging? So we'll try to identify those items. We'll also study the navigational charts, and we'll identify where the Army Corps of Engineers navigational channel is relative to your site. We'll identify any other federally protected dike systems or levee systems or erosion protection revetment systems. We'll identify all that as it relates to the project. Additionally, we'll do enough to try to identify everything, basically. There's a lot there, so I'm trying to pick and choose which ones to bring up. But another one is, buried pipelines running underneath the river or utilities that run over the top of the river, because oftentimes there's easements attached to those. And one last thing that we do, this image on the bottom here kind of looks like an EKG graph, but this is looking at the historical river elevations at the gauge upstream and downstream of your site. And we'll try to see that trend of, during what seasons is it more at low water versus high water, because that plays into the construction schedule. Also, it's good to know for the overall operation of your facility. So some more items on the phase one, so site selection. Another thing that's critical that we identify from a design engineering perspective is the intent and goal of the project. And this is basically, what's the purpose of this facility? What's the long-term plan for your facility? How does this site kind of play into the other facilities you have on the river? And that's just to get us kind of right on the same page as, the owner and what they want to do with this dock facility. The next one is facility capacity. So this is big because in phase one, this is where you want to start talking about the different capacities or having those discussions on what capacity do you want this dock designed for. Because once that, and do it in terms of, number of vessels per week or number of barges per day. And it's also good to identify kind of the peak shift versus the average shift, right? So your average shift might be 10 hours, but at peak time, is it 24 hours? Is it 16? Because all that plays into basically what is your total capacity, which then leads into what type of equipment do we need to use for this facility. And then that equipment, based on what that equipment is, plays into the operating procedure, which again then plays into the layout, which then plays into the overall selection of the dock infrastructure. So it all starts with that capacity. And it's very difficult to increase that capacity once you're into a farther design phase, like phase 3, when everything before it was defined on an initial capacity. So really just throw a wrench at it. So it's good to have that in phase 1. Another really good one is prioritize needs versus cost. So very often we'll get into a new dock project and we'll have this full wish list of all these different parts and pieces that we want to include on the dock. But what really helps us is developing some sort of a hierarchy for which items are more important than others, because that really helps the design team and the clients to kind of be on the same, see eye to eye on what's really important to them for this facility. So often we'll see things like safety and efficiency are up at the top of those lists, then low maintenance, longevity, and farther down that list would be plan for future expansion. That really just helps kind of us through the process trying to select the right piece of equipment, the dock construction, and a whole lot of other things. And then last one is budget and schedule, and honestly that's kind of one that you can spend a 2-hour seminar on, but it's really important just at the initial phase, what kind of budget are we thinking, and share that with the design team. That kind of tells us right off the bat, are we in the ballpark of what we're wanting to do here, and it just gives us a really good idea on how to be thinking as you go into that next phase of the project.
And I'll be honest, a lot of times the equipment suppliers aren't involved in phase 1, but it actually is absolutely critical. That is when you're determining the current that the system is running in, the max wind speeds, the elevations, really starting to talk about what your layout needs to look like and what equipment you need to do the job. So where Kevin said, you're developing that intent. Well, you can't accomplish that intent without the equipment. So really in this first phase, involving the equipment supplier, you're really looking at, okay, what can the equipment do? How much do I need to accomplish what my goals are? What does it need to be to operate in these types of conditions? And where does it need to be installed? All of that stuff has to be looked at in phase 1. So when you get to the point of looking at your dock layout, looking at your SOPs, you know what you need to get the job done, and you make sure that you do cover the intent of the project.
In our opinion, along with the intent of the project, I think the last two bullets are very important, and they really drive the conversation of the project from thereafter. We do enough budgetary estimates, with Kevin and VAA. We understand what these structures generally cost on aggregate, whether it's a tripod breasting dolphin, a quad pulling dolphin, a sheet pile cell. There are some variables, of course, that constrain the project to those certain structures, be it subgrade that we mentioned earlier. But with that, really you can identify a lot of those priority items and whittle that list down if you already understand what your cost, expected costs or available funds for that project are.
I think to build on what we talked about earlier with the intent and goal of the project, and how much product you're going to move through this dock at one given time is important too, but also future planning. If you can, future planning is hard, right? We don't know what we're going to be doing tomorrow, but we want to design our facility. If you're planning to grow, if we can do whatever we can on this first initial phase, and maybe it's not this project, maybe it's a project 10 years from now, but we want to have that in mind and design around that. So in the future, if you're planning on ramping up and unloading or offloading more barges, you can. So.
Well, and how many times do they come to you, a week after they put it in and say, hey, can we move 2 barges with this equipment? And you can't do it because that wasn't established in the front end. So even if it's something you're thinking about, making sure that's considered in phase 1 is incredibly important.
So I kind of look at phase 1 as this is the phase where you're identifying and defining the boundaries that the project is to stay within before it's really fully defined. So at the end of phase 1, before moving into phase 2, having these items are very critical. And again, that all plays into influencing the outcome of the project. So the next phase, phase 2, some important things, critical things from a design perspective is the equipment selection. So now you have the capacity set. We want to do 3 barges a day in a 10-hour shift. Then you kind of look at the equipment selection, the different type of equipment vendors and the size of the equipment that they provide. And you kind of align those two to be a good match. And once you have that equipment selection defined, then you move into operating procedures. So SOPs, which stands for Standard Operating Procedures. And this is a diagram of an SOP we put together for a client. And this is where we bring in the client ourselves, the design team, contractor, equipment supplier, as well as even the fleeting service. And you go through step by step, how are we going to use this dock to do what we need it to do? Because honestly, this is more so like developing an owner's manual for the dock owner to use the dock sufficiently. And you can see in this diagram, actually, for the actual, this was a barge unload terminal, and the actual unloading part of this didn't occur until step 5. What happens before that is, the barge has to be positioned into the right spot to get someone on the deck of the barge so they can help remove the lids. And then they remove the lids, and then that person has to get off the barge and then position the barge into the right spot to get the best efficiency out of the free digging from that material handler. So there's a lot of steps there. And what this also does, it is kind of a deep dive study of the operations piece, but it brings to the surface all the different pieces of equipment, the layouts, where our deckhand's going to be during this step, during the next step, and it really pulls out all the parts that you wouldn't see from a 10,000-foot view. And it really creates an opportunity to really dive in, find the most efficient way to do this to match what your operations team can do. So so then SOPs, and once the SOPs are defined, then you kind of build, you lay out the dock for that operational procedure. Then you can kind of start setting where different pieces of equipment are, how big of a dock space you need, what other storage or rooms you might need for your dock. So it kind of goes in this order, really smooth. And then once that dock layout is done, it's good to also at this time during phase 2 is to go out and get the geotechnical information and the survey work. And the survey, what I'm referring to here is the bathymetric survey, which gives you the contours of the riverbed. And this will tell you kind of at what depth do you need for the vessels coming to your facility. But the geotechnical is an important piece in phase 2. And getting geotechnical soil borings taken out in the water, for those of you that have gone through this before, they cost quite a bit more than a typical boring on land. And primarily that's because the geotech has to rent out a barge to put their drill rig on and bring it out to the site. But that cost is more, but it does more times than not pay for itself. And it either pays for itself through, fine tuning the exact pile heights and depths and tip elevations. And it also pays for itself to identify anything that was buried that you didn't know of before. Meaning, if you're assuming that bedrock was 40 feet down, but in reality at some spots along the front of your dock, it's more like 20, it's good to know that stuff way in advance in phase 2 before finding that out while you're constructing the dock. So it does more times than not pay for itself. Another one is other investigations required for regulatory permitting. So this is just permitting in general, and permitting, again, because you're designing a dock on a public waterway, there's always going to be a permitting piece to it. And this is a snapshot here. I asked somebody to put together a list of all the different agencies and permits and the rigmarole of the permitting for me, and this is what we've done so far this year alone. There's a lot of hurdles and hoops, and it's really critical that in phase 2 you develop you identify all the permitting thresholds. And what works really well for this stage is working with an environmental company that's very familiar with that region you're building the dock, and they've been through it quite a few times before, and possibly they may even know most of the people in the Army Corps' office, the DNR's office, to really help facilitate it. But part of going through all these different permits, and there's a lot of them, is a third-party investigation. And for some of these requirements, some of these permits, you got to meet certain requirements. So, for example, for cultural resources, you got to hire out do an archaeological study of the site to find any historical artifacts. You got to do a wetland delineation. You got to do. If you're building near a levee, you got to do a slope stability analysis of that levee to make sure that whatever you're building is not going to impact the original factor of safety of that levee. And the list goes on, but there's a lot. And the idea, though, is for phase 2 is to identify all those permitting thresholds and get all of our ducks in a row and make sure we're getting all those parts and pieces lined up so that when we do submit for permit, everything kind of just flows right through. And we're not kind of educated at the end of the permit when they say, you don't get the permit because you missed X, Y, and Z. That definitely throws a rock into your schedule. And going back to the phase 2, so permitting is a big piece. And then for phase 2, once the equipment selection is known, your operating procedures, which dictates kind of the dock layout, you got the geotech info. Now it's kind of where you start honing in on what type of dock infrastructure are you going to choose for this. And this varies depending on region. But a big part of this too is it really varies on constructability. So you can design anything you want, but how constructible is it? What's the best way to do it? What are some of the material costs that we should try to capture for the dock construction here? So all those discussions should happen in phase 2. And the last one is reevaluate budget. So once all these things are defined, again, you got the equipment, you got the geotech, you've got the input from the marine contractor, then it's time to kind of reevaluate your budget, know that most of this stuff is now defined.
And just expanding on the importance of those SOPs. I mean, when you are talking about using equipment to accomplish a goal, establishing how you're going to use it is absolutely critical. How are you going to interact with the equipment? Is it in location? Can it be maintained? Can you access the barges at all the times? This is really where you get the opportunity to sit down with not only everyone at the dock, but all the invested members inside and outside of that location, and even the deckhands, the people that are actually doing the work, getting their feedback and saying, do we have the proper equipment here? Can you interact with it safely? Can you do everything we're setting out to do here? And from an access perspective, is everything there we need for you to be able to operate efficiently? A lot of times this step does get skipped. And what happens is that you end up with a dock layout that doesn't match what you need, a set of equipment that doesn't match the criteria that you established in phase 1, and a project that has to be redone after it's complete. So really making sure that you go through that step, reevaluating against your budget and all your goals, and then doing it again, doing it 3 times. Sometimes we'll do it 5 times until everyone's sitting at the table and saying, this is exactly what we need, this is how we want to operate, and this is how we're going to do it.
Really, phase 2, I think the biggest takeaway I hope we project is, our entire presentation is that there's a process here. It's a project life cycle. But within phase 2, this is probably the most important to follow each of these bullet points. You can't design a structure without geotechnical engineering unless you're over conservative, which typically drives cost and materials and time for install. Back to the SOPs, we run a harbor service, our Brennan Marine operations do. We often consult them about how they bring a barge in, and then turn that into a constructability review with Kevin and his team. If we've designed a component of that project upstream or downstream of the main dock facility where they'll be actually fleeting a barge as they bring it in or take that back to the fleet, it really impacts what structure type that is, how it looks, how it's fendered, and can once again impact constructability of the project at large.
And when I was talking, I kind of zoomed over that layout part of it, but we have this slide just to kind of show in very basic terms, a dock layout. So when we're talking about the length of a dock, we're not really talking about just the infrastructure piece here. What we're referring to is the overall dock length. And for, depending on the capacity, you got to look at how many barges do you need to show up first thing in the morning at the shift, how much space do you need to load that barge, and then how much space do you need to kind of push once it's done with that process, push it off so you can start the next one. So the dock length is a big part of it. Of course, you've got your process and your purpose, and you've got the barge access system, which is critical. You got to be able to get on and off the barges safely. And then the last piece is, really huge part of this to make it predictable and easy to use for, the operational team is having a really good and thought through barge haul system to maneuver the barges from one end of the dock to the other. And this is something Kenneth can talk about here on this next slide.
Right. So see, the real key is to establish every single step. When it comes to interacting with the barges on marine terminals, it's one of the most dangerous things that happens. Not only because there's massive equipment moving big steel cables, but also because every time they access that barge, they're stepping over a gap of a river, moving anywhere from 3 to 10 feet per second. And so when you understand, especially for the deckhands, how they're going to do their job every day, how they're going to interact with the equipment, what the equipment's going to do for them, and what it's not going to do, they can operate with safety and consistency. Without that, they go out there, and Tim is going to do it different than John, and John's going to do it different than Matt. And I think anyone knows when you have inconsistencies like that, you have maintenance breakdowns, you have safety concerns, and quite frankly, you're putting people that don't know what someone else is going to do in harm's way. And by establishing exactly how you're going to do your process, you guarantee your dock layout's correct, your equipment's correct, everyone can operate safely, and everyone can do it the exact same way. And that's what we're after in phase 2.
I think communication is key there. I mean, we can dream it up on paper as much as we want, but until you have that conversation with the guy who's loading the barges every day, we see that get missed a lot, and we're guilty of it ourselves,
Right. When you exclude vested parties, not only do they feel excluded, they don't buy into the process,
right.
But then they come in and they don't do what you intended. So when you have the opportunity to give them documentation and give them a chance to talk through it and explain it and raise their concern, you get a chance to make the right decision before you're building the dock or investing in the project.
Yeah, phase 2 is very critical. And like Matt mentioned too, that out of all the phases that have the most influence on the outcome of the project, that's in phase 2. And the quality of, being able to identify all the parts and pieces comes, with the design team being experienced and knowing what to ask and what to look for. So that kind of sums up phase 2.
Are you guys doing like 3D modeling or anything to have those interactions with people that you're talking about?
Yeah, so the question was, are we doing any 3D modeling to interact the interactions of moving a barge haul or moving barges?
Yeah, any operation that you're talking about.
Yeah, so for the barge haul systems, we 3D model everything. That's how we do our initial concept delivery. A lot of times, we'll send that over to Kevin, or we'll talk with Matt about it ahead of time just to avoid any concerns. And then a lot of times, Kevin can take that and transfer it into GAs and his own SOPs. So it is a very powerful tool. We get to look at not only where the equipment is, where the lines are going to be, kind of freeze it in different locations, raise and lower the water level. And really be able to communicate every single aspect about the job before, again, you're making those finite decisions. So that's kind of a tool that I think we all use integrally to kind of make the right decisions and communicate that to everyone that's involved in the project.
It's an easy way to communicate to the owner what the end product's going to look like. At the same time, we use VDC on the construction side to show our guys that are out there driving those piling, welding those cavils on, installing Kenneth's winches, what the process looks like from start to finish. It's a good tool. It really improves efficiency and safety from that standpoint. a new guy on site knows what the final product looks like as he comes on day one or midway through the project. So he really has an idea of where things are heading and what to look for.
Well, and you got that guess and check, right? If you see our models and I go look at your G&A and it doesn't match what's in my model, we know we got to communicate. And likewise, if you have something that pops up in your construction plans that doesn't match something that Kevin has in the GA, now you guys got to communicate and make sure it's resolved before there's a problem. So that's a really useful tool in today's industry that we all utilize.
Catching them on the front end is a lot less expensive than when you catch it in the field with all that equipment out there. And
5 minutes to change a model, 5 months to change a dock.
yeah.
Yep, that's all it took. Okay, good. Kind of moving on. So phase 2, that's where a lot of all this stuff, all this discussion happens. Things get fully defined. And then once that's all done, then you move into the final engineering phase. But the final design phase really depends on what type of construction procurement method that you choose to use to construct your dock. And there's a number of different mechanisms. You know, there's the design build, design bid build, and the cost plus. And from a design engineer's perspective, what we do in phase 3 varies very much on what this construction procurement method is. So for design build, kind of a pro to this is if the owner's engineer did everything that we talked about in phase 1 and phase 2, and then also was able to really successfully document all that information into a really good set of bid documents for the design build contractors, I've seen that go really well. On the other side of that, though, if there's a lot that was missed in phase 2 or phase 1 really didn't happen, and then you send out a design build package for a design build contractor to bid off of, there's a lot there that a really highly qualified marine contractor that does this stuff day in, day out will recognize, and they'll have to capture that risk and that cost into their bid. And oftentimes, or sometimes, the lowest bidder might be the one that kind of is not familiar with that type of dock construction or that type of facility, and they weren't able to capture some of those items. But the next one is design bid build. This is kind of nice from the original owner's engineer goes through phase 2 and then quickly jumps into phase 3, the final engineering design. That can start a little bit sooner, meaning that you could probably submit for permits a lot sooner with that process. The con to this, though, is unless the marine contractor was in really close communication with the design team, there's a lot there that a contractor, the value of the contractor won't be reflected. The contractor would have to bid off of something that the engineer assumed would work just fine and didn't really capture the value added from a marine contractor familiar with that area, with that region. And the last one is cost plus, and this is kind of my opinion and just mine. But I have always found that for cost plus setups, you're working with, you're basically working with that, what I showed on that Venn diagram with the 3 circles. You're working with that team from the beginning of the project through phase 2, phase 3, and you're building the project together. So from an overall planning standpoint, that one worked really well, and it was a lot faster. There's a speed in the design schedule because you're able to submit for permits faster, there's coordination happening a lot quicker, and then even procuring materials can happen a lot sooner too.
And with all types of contracts that are involved in these projects, I think the one thing that I'll say is just understanding the necessity for familiarity. The fact that the parties are involved in the process, even if it is a design bid build where there is this handoff period, there's at least a point of having people communicate. So the fact that the intent of the design, the intent of the equipment selection is transferred appropriately. There's plenty of times where I know you get handed something to procure equipment and don't really know why they picked that, but they did. And at the end of the day, it ends up falling on you. So when you actually have that familiarity, regardless of which type of contract it is, that really guarantees that you have success.
I think the simplest way to describe the difference between all these is it's a balance of time versus risk and cost, and which party assumes which, be it primarily risk. I will say the design build, this is a project we actually did with Kevin and his team. It allowed us to procure the walkway and permanent materials really while permitting was being done, and while we were actually on site building the superstructure of that dock. It also made the implementation of change orders a lot smoother because Kevin knew what the design assumptions that he designed the loading for on that superstructure, what capacity those were at. We were able to add a jib crane to this to handle some larger commodity hoses the owner wanted. The project really went on a truncated schedule. It really got pushed because that, I don't know if we mentioned permitting earlier, but that took longer than the owner had expected. But really, we were able to overlap those major project activities.
Yeah, I think a lot of owners, they shy away from the cost plus. You see the open book, and that sends, red flags to an owner. But if you have a team in place and you trust your team throughout the process, you can actually save money and flatten that curve, on the right-hand column on the graph we showed earlier, because you may not get hit with change orders and things of that. It's also time. I mean, we hit on it. You share the risks and the rewards depending on which process you go with.
Absolutely. So that was phase 3. We're going to not really get into phase 4, the construction piece of it. That will be for next year maybe. But what we'll do next is we'll just go through each of us, kind of just hit on a few critical factors from our perspective, from the design engineer, the equipment supplier, and the marine contractor. So from a design engineer's perspective, one of the biggest, most impactful thing is working with an experienced design team. And that goes for the marine engineer, people familiar with the process that the dock's going to be used for, working with experienced equipment suppliers, and very important, working with experienced marine contractors. Because that just all plays into influencing the outcome of the project. And really, if you're not familiar with it, you're going to be kind of learning as you go along, and it creates a lot of risk for the client, and again, kind of impacts the outcome of the project. The next really important one is time spent researching the site. This is that reconnaissance work I was talking about. There's been so many times where, there's so much buried. There's a lot of buried bombs. I guess to help explain this, one example was we had a project where everything was going smooth. Construction was right on schedule. Marine contractor went out to the dock to start installing the first set of piling. And right when they dropped the piling, it hit like a bed of just existing steel cables. And what was there is, it was, for that existing facility, they ended up removing the barge hull cables, dumping it into the river every time they swapped it out. And that facility's been there for decades. So that ended up putting the brakes on the entire construction schedule, and they spent the next month removing about 4 miles of cable from the bottom of the river. So that reconnaissance work's important. In hindsight's 2020. I wish I went out there and asked for them to do probing to kind of just dig around where you're gonna build, and we could have caught that in phase 2. So time spent, the reconnaissance work is really important. The third one, facility capacity, is definitely a major thing, because again, everything follows after the capacity is set. The equipment selection, the SOPs, the layout, the dock construction, it all matches, because again, all these parts and pieces have to get harmonized to do the process that you're wanting to do, and it all matches a certain capacity. And then, SOPs, bullet number 4 here, that's important. That's that deep dive study, getting everyone involved from, the owners, the project managers for the owners, to the actual operating staff, to the fleeters, to the marine contractor, and the equipment supplier, and just walking through all these different steps of that, of using that facility. And the last one is overestimate the permitting requirements. And this one, more times than I ever thought I would here. I've been in projects where the client was given some bad information, or maybe overly optimistic, and they'd say, for this dock expansion, we only need about a month to 2 months for that permitting piece. And every time I hear that, it never happens. There's always something that pops up. And like I showed on that previous slide, there's just so many agencies, and the legal landscape's changing. Depending on where you are, it's a really cumbersome process. Like if you're in Portland, Oregon, in order to get through that permitting piece, there's a lot of hurdles to go through, and same with New Orleans. But that's kind of changing. There's more and more sections of the Army Corps of Engineers district kind of adding to it.
I will piggyback on that last piece too when it comes to schedule. Overestimating a little bit and being realistic. In today's day and age, supply chain, we all know, is a big issue. I order controls today, it'll be 4 weeks. I order them tomorrow, it'll be 4 months. So that is something always to consider. But from an equipment side of things, really understanding your capacity and the criteria you're going to be using the dock at is extremely important. I don't know how many times we end up in a situation where the equipment's either not capable of doing it or the equipment supplier wasn't involved to the point where they actually get to talk about how the equipment is going to be used. And what happens there, again, is your dock, the dock that you built for a specific intent, is not able to accomplish that. And so that is, again, one of the worst scenarios to be in. Now, it gives these two guys more work, but it is never good for the initial owners or the investment. So understanding that initial criteria, locking it in, and discussing it and thoroughly making sure that it is exactly what you need is extremely important. In addition to that is the SOPs. Making sure that, okay, you now have your criteria, you've talked through it, it's locked in, you're good to go. Can we accomplish it? How are we going to accomplish it? Do we have the equipment to accomplish it? So those two pieces go hand in hand on phase 1 and phase 2 to make sure you get to the final goals that you're after. When you do those two things, you can operate safely, you can operate efficiently. Without them, you end up with a phase that in the industry we hate as an equipment supplier, which is we just make it work. We never want to hear that. We never want to see someone go through that because that's not safe, that's not efficient, and that doesn't have to be that way. So accomplishing those things in phase 1 and phase 2, having everyone involved in the process can really make sure that you're successful in the long run.
I'll keep ours brief because I know we're running on time here, but I think similar to Mike's presentation earlier on rail, marine is there are frogs and fish, and here we've got cavils and bollards and barges, and the terminology is very nuanced in marine construction. So selecting that project team with the partners we've showed up here is very important to project success. Another main one is the project schedule. You all as primarily owners of facilities or owners of facilities in general know where your cash flows and revenues are seasonally and whether or not a project can be performed on a phased basis, one at a time or during a seasonal outage has a large impact on delivery of that project in a certain amount of time. It also drives cost, up on the Illinois and Mississippi rivers specifically, navigation shuts down in the winter. So we typically really have a more construction on the locks and dams, but our private work kind of slows down also, but it's cheaper for us to do it in the winter during a seasonal outage like that. Lastly, I think that's it. The dock constructability is the big one that we run into with Kevin and Kenneth quite a bit, as far as them having an initial project and concept design. We'll review it to give them really a budget and a cost or optimization of their design from there, or suggestions so they can run to see if project criteria and loading are still safe as far as project intent is concerned. So I think that's all I have.
Okay. What we'll do next is I'll just sum it up while we kind of show you get you some eye candy of a construction photo taken from a drone.
These are some of our projects, I think through the last 5 years we put in place, but you'll see a lot of the dock types we just discussed here.
Enter. I guess while that's playing, just to sum it up, marine construction, the design of marine facilities, it's very specialized, very unique, depending on where you're constructing that dock, depending on the process you're using it for, depending on what vessels you're using it for, depending on, what Army Corps of Engineers district you're applying permits for. There's just so many parts and pieces that it's really critical to engage kind of the design team consisting of a marine contractor, equipment supplier, alongside the design engineer. And those projects were only one or two of those circles, like I showed in the design diagram, were used. That just creates risk of not unearthing and identifying those unknowns. So I hope you guys enjoyed the presentation. We'll open it up to questions. I know we're 4 minutes over 4.
We got a few minutes. Anybody have a question for these guys? I got it.
So you talked mostly about new construction. how much of, I guess, your work is on like the repair side of things, and what are some of those common repairs that you see out there?
It's funny you bring that up, so I don't know if I need to repeat the question or we're good on the mic there, but we do a lot of repair work. I'd say 70% of our work is repair work on existing facilities, and we kind of joked while we were preparing this presentation is that a lot of the repair work is done because those steps between phase 1 and 2 really weren't followed, and the intent of the project was different than the capacity as designed and implemented. So a lot of our work is going back to retrofit an existing dock and either upgrade it or repair a damaged structure that wasn't designed to the capacity that it was used to.
Some of the common repairs are, fixing split piling or patching sheet piling walls or spout bearing replacements, dive inspections, some concrete, fixing structural steel on a dock, just a couple examples. But yeah, the make it work sometimes makes it work for a while, but not forever. So a lot of it is repair work.
You'd be surprised about 20% of our work when it comes to barge hull systems, because they are so specialized, is actually relocating existing equipment or putting controls over the top to make them accomplish what they should have accomplished in the first place. So it's much more than just on the front end. On the repair side of things, you see it all the time, where you skipped a phase and you have to reuse that same equipment that they bought 2 years ago or change it because it can't do what they intended.
That was a good question. Maybe to add to that too, I mean, if you go along the Mississippi, you have all these existing facilities that were built in like the 1950s, 1960s, and throughout the course of the life of that dock, it's changed hands maybe 3 or 4 times. The process has changed. So a lot of the work that we do too is kind of, they've been making it work with whatever, arrangement they have. Now they're taking that opportunity to make it more efficient. It's a good question.
That was a great question. I'm going to step in here. I think you guys will be around, right? So if you have questions, come on up and meet with them. But I just want to say thanks to everybody for coming today.